Okay, last video of our lesson, we are going to look at trig ratios in special triangles. You have worked with these before. It's been since geometry. These are your special right triangles specifically. We have two special right triangles. You've got your 45, 45, 90 and a 30, 60, 90. So let's draw those triangles in. We've got some information we need to remember about those, and then we can apply it to the examples in the video, in the problem, in your notes. All of the above. All right, so a 45 degree triangle, that's an isosceles triangle. Let's just make a note. Say, oh, isosceles triangle. Isosceles triangles have two congruent sides. So if you have a 45, 90 triangle, here's what it looks like. I just said there are two congruent sides, so these two sides will be the same length. So anytime you're dealing with a 45, 90, we know that two of our sides will be the same length. We are going to use specific labels for our three sides. They are proportional to each other in the same way for every single 45, 90 triangle. Right now, we don't know any of the side lengths, so let's just call this side x. Well, if that side is x, guess what? This one is x also because it's an isosceles triangle. We could go through Pythagorean theorem, x squared plus x squared equals our missing side squared. When you do that and solve, our hypotenuse of a 45, 90 triangle will always be that side length x multiplied by a root 2. It just works out that way every single time. Another special triangle we have is a 30, 60, 90. This one is not isosceles, so you don't have two congruent sides. But a 30, 60, 90, one thing to think about is you've got your 90 degrees. The other two angles, one of them is going to be a smaller angle. So the smaller angle will be your 30-degree angle, which makes the other one 60. And these triangles have the same labels. They're proportional to each other in the same way every single time, regardless of how big or small this triangle is. We start with opposite of the 30 degrees. That's where our x goes in this triangle. The hypotenuse is always twice as big as that side, so our hypotenuse is always 2x. And then our third side, which goes across from your 60, is always x times root 3. So we do want to memorize these three side labels for these special triangles so we can apply them to any example. Anytime it's a 30, 60, 90 triangle, we've got side lengths we can use to help us find all the missing sides. Okay, let's look at an example. Triangle MNO is a 45, 90 triangle with side length OM equal to 2. Well, let's draw this out first. So we have a 45, 90 triangle. This is going to be M, N will be here. Here's O. We've got a right angle. Remember, we have two congruent sides. It is isosceles, and here's our 45 degrees, 45 degrees. So there's our 45, 90. They told us that OM is equal to 2. So we go to our triangle, we find side OM, and we label it 2. All right, so if we look at our 45, 90 triangle above, what else do we know? Well, we know that it's isosceles, so these two sides are going to be the same length, so this must be a 2. And then we know that MN is going to be that side length times root 2. So 2 times root 2. Again, we could have found that with Pythagorean theorem, but because it's a 45, 90 triangle, it's going to work out that way every time. Now we are asked to find the 6 trig ratios for angle N. So let's focus on angle N right here with measure theta. So they're just telling us to use theta when we write out our trig functions. Because we're going to go in terms of N, we'll label our triangle for N. Across from N is the opposite side, so here's the opposite. Our hypotenuse is that 2 root 2, and the adjacent side is that 2 on the bottom. Now we can find our 6 trig functions. We know all 3 sides of our triangle, and we know what angle we're using. So even though it's angle n, they told us to use theta, so sine of theta is equal to the opposite side, 2, over the hypotenuse, 2 root 2. All right, so we are going to run into some issues. You can't have a square root of 2 in your denominator, and this 2 over 2, they cancel each other out. They divide and equal 1. So those cancel. We are going to rationalize. We multiply the square root of 2, top and bottom, by square root of 2. So in the end, our numerator is a square root of 2. Our denominator, square root of 2 times 2, square root of 2 is 2. So sine of theta is square root of 2 over 2. Cosine theta is the adjacent side over the hypotenuse. Adjacent is 2 over 2 root 2. And we notice we might have some repeats. We just did a 2 over 2 root 2. So I already know that it's going to simplify to this root 2 over 2. So I am allowed to use previous work and say, all right, that's a square root of 2 over 2. I don't need to rationalize again. I don't need to cross off the 2's again. We already showed our work above on that one. All right, tangent of theta is the opposite over the adjacent, so 2 over 2, and that does reduce, so we are going to go ahead and say that equals 1. So those are the first 3 trig ratios. Let's find the reciprocal trig ratios. Reciprocal to sine is cosecant of theta. So if we go back to the original opposite over hypotenuse, that's the one I want the reciprocal of. If we flip that, we have 2 root 2 over 2. Your 2's will cancel, leaving you with just a square root of 2 over 1 or square root of 2. So cosecant of theta is square root of 2. Reciprocal to cosine is secant of theta. Again, we go back. I like to go back to our original setup. I could go to this square root of 2 over 2, our simplified answer, but the reciprocal of square root of 2 over 2 is 2 over root 2, and then we're just rationalizing again. So I like to go back to the original to save myself a little bit of work. I know that that's going to be 2 root 2 over 2, and we already know that simplifies to a square root of 2. Then we have cotangent of theta is the reciprocal of 1, which is just a 1. So we got our 6 trig functions. Okay, so kind of get the idea. Let's do one more, this time with a 30, 60, 90. So we'll draw out our triangle. There's our 90 degrees. Here's our 30, the small angle. Here's 60, the bigger angle. We're going to label this one. We'll put the K up here, the L down here, and the J here. Okay, they said that side length LK is equal to 4. So if we go to LK, we're going to set that equal to 4. And then we also know that the measure of angle J is 30. That's why I put the 30 down there. I already had drawn that in my own notes. So J is 30, LK is 4. Now if we go back to our 30, 60, 90, whatever side is opposite the 30 degrees, we know the hypotenuse is twice as long. And we know across from the 60 is root 3 times whatever that side length is. So I'm just going to use those same labels and substitute in now that we know one of our side lengths is 4. The hypotenuse is twice as long, so 2 times 4 gives us a hypotenuse of 8. And then across from the 60 is that side length of 4 times root 3, so 4 root 3. They want everything in terms of angle J. Again, we're going to use theta, but in terms of angle J, we want to label our triangle. Opposite of J is over here. Our hypotenuse is this 8, and the adjacent side is 4 root 3. Now we can set up our 6 trig functions. So sine of, instead of J, they want us to use theta. Sine of theta is opposite over hypotenuse. So 4 over 8, that one will reduce to a 1/2. We'll move on to cosine of theta is adjacent over hypotenuse. So 4 root 3 over 8. The 4 and the 8 right here will reduce. 4 over 8 reduces to 1/2. So 1/2 gives us a 1 root 3 or root 3 over 2. And then we have tangent of theta is opposite over adjacent. So 4 over 4 root 3. So two things here, your 4's will cancel. 4 divided by 4 is 1. And then we have to rationalize. We'll multiply the numerator and denominator by root 3, leaving us with a root 3 on the top. And then square root of 3 times square root of 3 is just 3 on the bottom. So tangent of theta is equal to root 3 over 3. All right, let's do our reciprocal trig functions. Reciprocal to sine is cosecant of theta. So we're just going to take our 1/2. The reciprocal of that is 2 over 1, or 2. Reciprocal to cosine is secant of theta. We could take, the reciprocal of our final one here. I think that'll work out. 2 over root 3. But we have to rationalize. We're going to multiply top and bottom by root 3. That's going to leave us with a 2 root 3 over 3. And then last we have the cotangent of theta. Cotangent is the reciprocal of this. So if we just flip that, we get 3 over root 3. Let's rationalize. When we rationalize that, we get 3 root 3 over 3. And then guess what? Those 3's are going to cancel. So the cotangent of theta is just a square root of 3. Whew, that was a lot in that video. Hope you guys stuck in there to the end. Looks good, doesn't it? All right, special right triangles. There you go.